All right, we were working in section 2.2 last time. We had encountered several basic derivative rules. Just a real quick run-through reminder of what those rules were. We had the constant rule that says that the derivative of any constant, any number, that means is 0. We have the power rule, which is the derivative of anything that has an exponential, right? A base that's a variable x raised to a number, and that number can be any kind of number, positive, negative, radicals, fractions, whatever you like. And you bring the exponent down, and you decrease the exponent by 1. And then we had this freebie that kind of associates with that. That's sort of an in-between of those two things, the linear rule. The linear rule says that if you have a line, the slope of the line is the derivative, because that's what we mean by derivative is slope. So it's just y prime is m. And then the constant multiplier rule, which relates to all of these different rules actually, says that if we have a constant times the function, that constant is times the derivative of that function as well. So the constant sort of just comes along for the ride. Couple more, we had the sum and difference rules. When we have addition or subtraction of functions, then their derivative is the addition or subtraction of their individual derivatives, which is like everything we would want to be true. Like that's a very cool fact. And you will appreciate it much more when we get to 2.3 and find out that doesn't work for products and quotients. It only works for sums and differences. And then the derivative of sine is cosine, and the derivative of cosine is negative sine. And that puts us at where we left off, which is example number 6. All right, so example number 6 says that we are supposed to find the slope of the graph of the function at the given point. So this phrase, you might want to make yourself a note card or write down somewhere in your notes that there are several words that mean the same thing. All right, slope of the graph, slope of the tangent line, and derivative are the 3 that we've encountered so far. We will shortly, I can't remember if it's today or in the next couple lessons, encounter the phrase velocity, and specifically instantaneous velocity. That's another one that means the same thing. But whenever we see this phrase right here that I've circled, slope of the graph, it means derivative. Okay? So we're looking for the derivative of the function at the given point. The given point business means that at the very end, we're actually going to evaluate our function that we get. So it's sort of one step beyond what we did last time. If we were doing the same directions on these problems, we would have done everything the same, except at the very end we would have been given an x value that we would have evaluated this at. So we have y equals 3x cubed minus 10. So what we're supposed to do first is to find the derivative. So what is the derivative of 3x cubed? 9x squared. And the minus 10? That's 0. Yeah, that's 0. So we've got 9x squared, and then we're supposed to be evaluating at the point 2, 1. So one way that you can sometimes see this is you'll see evaluated like this at the point 2, 1. This is one way to write it. You could write it y prime of 2, because 2 is the only number for x that we want to plug in for. That'd be another notation that means the same thing. What it means is we're going to plug the first value, x value, in for x. So
can you do like the line and then write x equals 2?
You could. That's another option. You could write like that. Let me write the one went down that you just mentioned. Yep, that's another way that I've seen it written. All of these mean the same thing. They mean plug in 2 for x. Okay? So whichever one you're using, I'll just use the last one since I've got the space over here. You're going to do 9 times 2 squared. Please be careful. What's squared? 2. So order of operations, we square the 2 first, right? Mm-hmm. So don't multiply 9 times 2 and then square that. Mm-hmm. It's not left to right. There's some things in math that we do left to right, but exponents we do before multiplication. So 2 squared would be 4, and 4 times 9 is 36. So 36 is actually the answer to our question. This confirm your results with the calculator. Let me show you what that means, because there are some pretty cool calculator kinds of tricks that you should be aware of. I'm not a big, a big fan of like teach you how to do it with the calculator, so you don't need to know how to really do it. That's not the point. But you have a calculator as a resource, and you should know how to use it to confirm your results. And I think that's a very practical kind of application of the use of the calculator. So I am going to show you how to do that. What I'd like for you to do is in y equals, put in the original function that you were given. So that's the 3x cubed minus 10. Yes, sir?
How did you jump to the 9x squared?
Oh, that's a good question. Where did we get the 9 from, guys? Yeah, it's the power rule. So if you've got that exponent of 3, that exponent of 3 comes down to the front, and there was already a 3 there, so we just multiplied it. 3 times 3. That's the 9. And we decrease the exponent by 1, which is a power of 2. Yes, Thank you so much for asking. I would much rather you guys ask than to be like, I don't know what she just did, and I feel like other people do, so I'm just not going to say anything. So thank you so much for asking that. I appreciate that. Excellent. Okay. All right, so in y equals, we're going to put in 3x to the third minus 10.
Oh, sweet. That's cool.
Okay, you guys good with this? All right. Here's the cool stuff. There's two ways to do this. I'm going to show it to you first. I think I'm just going to show it to you in the regular screen first. So just go back to a regular old plain old screen, not the graphing. We're not going to graph anything on this one. We graphed last time a tangent line, but we don't actually have a tangent line that we just created, right? We just found the evaluation. We found the slope. That's all we found. Okay, so inside of your math button, so if you hit math, and you go down to number 8, it says in deriv. What do you think that means? Derivative. Okay, so we're going to select that. I'm going to show you what my calculator screen looks like, and then I'll swipe one of you guys that has a cool, cool screen, and I'll use that one. So let me show you mine first, so for those of you whose looks like mine. What you would do next is you need to tell it what the function is. So you could actually type in 3x cubed minus 10. That would be fine. Because we put it in y1, I tend to use y1 right here. So you might be like, okay, well, where do I get y1? I know where to get x. It's right here. I see it. Well, you get it underneath vars. Vars means variables. Okay, so hit variables. It is a y variable. So I'm going to go over to the y variables. I'm working with functions. It's the only kind of things that we're going to work with for quite some time in calculus. You do get to the other types of ones in another screen.
Selected the wrong thing in math.
Mm-hmm.
So which
Just
one
press.
was-
It's 8. It's
Okay,
math
I
8.
hit 8 and like
Or you can just go to Alpha F2.
Yeah, there's two
Okay.
different, yeah, so hold on tight to that.
all right.
There's two ways that your calculator screen shows it, and what yours actually shows, it does look quite different.
Yeah.
So yeah, just hold tight. If yours is not looking like mine at this point, just hold tight. Okay, so we're working with a function, so I'm going to select function, and then our function is y1. You have to put a comma next, and you have to tell it that your variable is x. So comma x. The comma is underneath the sign button above the 7. We're going to put another comma, and we're going to tell it what we want it evaluated at. And our value is 2. X is 2, so I'm going to put a 2. And if I press enter, it tells me 36. Now, my calculator actually has this .000, and it has a 3 at the end. It's a good question. Why is that? Because your calculator's not using calculus. It's using numerical limits of integration. It's using those tables. Remember when we did those tables?
Yeah.
And it's approximating it. So it doesn't quite hit it. We actually found it with mathematics, right?
Smarter.
We're smarter than the calculator today, yes. So I'm going to borrow Mooney's calculator so you can see what it looks like the other screen. Okay. So again, if you put it into y1, I'll put it in here just so you can see what it looks like from the way I was doing it. Oops, not
Oops.
squared.
Yeah, it's too bright.
Oh my goodness. Well, hang on just a second on that.
Are you changing my setting?
No. I'm not going to change your settings. No, of course not.
To format everything. I forget
Minus 10.
like,
Okay.
everything. Hey.
I think that's visible on, right? Okay, so I put it into y1. Again, you don't have to do it that way, but if you do math, again, it's math 8, and it says in deriv, okay? And it pulls up derivative notation. We haven't talked about all the notations for derivative, but this is one of them. This d with the little d down here says it's the derivative, and the d part of the bottom means with respect to what variable. So what's the variable we're doing the derivative of? So x is going to go right here. So this is saying I want the derivative with respect to x. Right here tells us the function's name. Well, you could type in 3x cubed minus 10. That's okay. Or you can do the same variables thing that I did before. It's vars, y vars, function, y1. Either way it work. And then over here at x equals, this is the notation that was mentioned before, x equals 2. And you press enter, and there's that 36 with a little bit of a rounding error at the end. Yes?
Why is there like a line?
That line means to evaluate. It's an evaluation line. So it's saying evaluated at. Yeah, it's the same kind we drew. Yeah.
It also worked if you put the equation there.
Yep, it will also work if instead of writing in y1, you actually type in the equation into there. I like doing the y1 simply because a lot of times you're asked to do multiple parts of something. You might also be asked to graph it, and you might also be asked to do this, and you also asked to do that. So I kind of like to use the y1, but it's certainly not necessary if this is the only thing you're doing for sure. Okay, so what I just showed you on the calculator is not sort of a requirement to doing our classwork, right? It's just a check step. That's all it really is. This is just a check step. It's a way to use technology to confirm what you did with calculus. Okay? Thank you. All right. I think we've got another one of these examples, don't we?
Or is it clear?
Oh, and it's a sine one. Same directions, huh? Find the slope of the graph of the function at the given point. That means take a derivative, plug in x. Use the derivative feature of your calculator to confirm your results. So this one says f of theta. Remember, theta is just a variable like saying f of x. F of theta, so we were going to find f prime of theta. So what is the derivative of 4 sine of theta? 4 cosine theta, very good. And then the theta at the end is just a variable. It's like saying minus x. It's linear, right? So its coefficient is its derivative. It's 1. Right, what's the slope of y equal x? Well, it's 1. So what's the slope of y equal theta? It's 1. Because the coefficient is the number in front, 1.
Oh, yeah, that's coefficient.
Okay, it's just the coefficient when it's a linear term. So this is the derivative. This is really all the calculus of the problem. After I do that, there is no more calculus involved. Everything after this is going to be algebra, okay, because we're plugging in a number, or trig in this case, because we're dealing with sine. So we're going to plug in f prime of, and what was theta?
0.
Said 0. Okay, so I need 4 cosine of 0 minus 1. Theta was evaluated at 0 on this graph. So what is the cosine of 0? It's 1. That's a unit circle value, right? So this is the number 1. And then I have, oh, I'm getting ahead of myself. 4 minus the 1, which is 3.
I have a question.
Yeah.
So if the way, though, like how the Garrett says, how the Garrett say,
Mm-hmm.
how do we do? How would
Like the notation?
Yeah.
If you were to use the notation here, you would do theta equals 0. And you could keep going from there at the end.
Oh, you can just.
You could.
That's
That would be
simple.
okay.
Oh.
Yeah. There are just lots of notations. That happens a lot in math where we have multiple ways of representing something.
Okay, but would you prefer that way?
It doesn't matter to me. I mean, there are things you can certainly do that would be incorrect, but any of those methods we talked about are fine. Okay, grab your calculator. I want you to try those steps we did before. I'll verbally say them again. I don't want to show the screen just because it switches out my technology, but let's try them together. So you're going to hit y equals, clear that out if you want to put it in y equals. Put your equation in. 4 cosine of x. You can use x too. You don't have to change the variable. So 4 cosine of x, and then minus x. We're going to do math 8. You need your function to be y1. You're evaluating it at x, and the x value is 0. Hang on, did I screw mine up? Oh, I did. I typed in 4 cosine of x. I meant to type in 4 sine of
I
x.
get awfully close to screen.
4 sine of x is what I meant to type in, so sorry. Okay, so is anybody having difficulty with the steps in the calculator to confirm?
I didn't have difficulty with the steps, but I came out with a very long thing.
Okay. Make sure you're in the right mode. What mode? You're in degrees. We need to be radians. So try it again. In fact, I have to screw this in a second. Yeah, it should fix this. Perfect. Is anybody else getting a weird value that doesn't make any sense? Check to make sure your degrees and radians. Modes and radians.
Are we always in radians?
For calculus, we are. Yeah, for calculus. In trig, we switch back and forth a lot.
Okay.
But in calculus, we will always be radians.
Bro. That's
Do we
true.
develop-
0.99.
You have to put it all in your function.
Maybe I should do that.
But it should be sine.
Oh.
Yeah. You have to do it. Make sure it's not on radians. I mean on. Make sure it's on radians. I don't like it. It's so confusing.
Now, there's a couple of this first thing over here.
Probably. Yeah. So it's and we did the math correctly. Then you
Error.
Is there another one in there? I have all of it.
Okay.
Okay, is everybody getting an answer that's almost 3 in your
All of it is
calculator?
like you just started like.
Is almost 3 coming up? Is anybody's calculator not saying almost 3? Christian, are you good on yours? Is it working?
It's
coming.
when someone says,
You can get the-
I love when he says,
Yeah.
I love it.
So the answer is, oh yeah.
You know what? Google is like everybody's best friend. So if you Google it, you can probably find it too, even if you can't seem to find it in the manual.
So I'm assuming you want us to like write it all out on the test and not use the calculator.
Okay.
Yeah, you're going to write it out. The calculator's just a confirmation for you. Exactly. Yep. Like what I've got on my screen is what I would expect to see written out on a test or a quiz.
This is
Fabulous
for the
questions.
check.
Yes, the calculator is for a check step.
Yeah, we can't really draw
Got it.
calculator, but I approve.
Yeah, not exactly. Okay, do we have another one or two? We have a couple more. All right, let's take a look. Goodness. All right, how are the directions on this one different than the last set? Yeah. We're going to find a whole equation when we're done on this one. The last ones we stopped with finding the slope. We didn't actually find the whole equation. We just found the slope of the equation. And then it wants us to use the graphing utility to graph the function and its tangent line. Okay? So that's a little bit different than the directions in the last set as well. We aren't just confirming the number evaluation point. We're confirming it by a graph of the two functions together. So first thing to do is to find the derivative. So I want everybody to zip your lips for just a second. Write down what you think it is. Just based on the rules, exactly. We're just using just plain old basic rules. Exactly. Okay, what did you get for the x to the fourth part?
4x cubed.
Okay, did everybody get 4x cubed? Okay, good. What did we get for the negative 3x squared? Yep, minus 6x. Very good. And how about the plus 2 part?
0.
0. Constants, no matter what they look like, just become 0.
Isn't it because like 2x sub O? Like,
Yeah, it's because 2 is a horizontal line and the slope of a horizontal line is 0.
yeah, it's like the way I like mathematically understand is like it's 2x. But
To
it's
the 0?
up to
Yeah,
0.
you can do it that way
Yeah.
too. Yeah, it's true. All right, so we'll use the same notation that we were talking about earlier, and we're going to write down that this x value here that we're going to evaluate this at is what?
2.
2. All right, so if we evaluate this at x equal to 2, I've got 4 times 2 cubed minus 6 times 2. 2 cubed is,
8.
times 4 is, what?
32.
32. Okay,
I'm
good.
dumb.
It's okay.
I
And
should
6
write
times
that.
2 is
Oh.
12, and then the subtraction is 20. All right, so our slope for our line is going to be 20. Now, your book is actually very friendly because it gives you the x value and the y value to plug into the line. You have no idea how friendly that is. I mean, not that you shouldn't be able to do that given the x value, but a lot of books will just give you the x value. They won't tell you the y value. So your book is friendlier than most. So when we're finding our function, the function notation that I use, or the line notation that I use, is y minus y1 equals m times x minus x1. They give you y1 is 6. You just found that m, the slope, is 20. And then they give you that the x value is 2. Now, we are going to have to plug this into the calculator. So while this is true that this is an equation, you had mentioned this last time, right? Technically, we're sort of done. It's not in a form that we could actually put in the calculator. At the very least, I need to move the plus 6 to the right. That's the very minimum of what I need to do. But putting it into point slope form is often just helpful. So I'm going to do that next. So this is y equals, I've got 20x minus 40, and then I'm going to move my 6 to the other side, plus 6. So the equation in slope-intercept form is 20x minus 34. Is everybody good with that? Okay, go ahead and take your calculator. I want you to put 2 equations in the calculator. The very first one they gave you, and the final one that you found for the slope of the tangent line. I'm just going to use a standard zooming window, so that's a zoom 6. And we'll see how that looks. We have a fun graph that looks like a W. And we have a line that's very, very steep on the right-hand side. This one is not terrible. It's probably not the best window we could be looking at. Is it better than zoom fit? I would at least think that we could stick, if we wanted to, with the top right-hand quadrant. So if you wanted to minimize and make this so that it was a window from x min is 0, and y min is 0, that would seem reasonable, because nothing seemed to be happening. And you might want to make your y maximum a little bit higher. Clearly that's going off the screen very quickly. So I'm guessing, let's just try 100, because it's really steep, and just see what happens. Yeah, that's not great, because down here is where we actually are crossing, right? So I'm going to take my window one more time. I'm going to make my y, our x value we're considering is the x value of 2, so I'm just going to make my x max go to 4. Okay, so it's evenly around the x equal 2 from 0 to 4. Still not great, but you can see a tangent right here, right? I think my y max at 100 was probably not the best choice. If you do 10 and 10, like 0 to 10 and 0 to 10. Yeah, it's not bad. You can still see a little bit down here that it's not tangent and a little bit up here that it isn't. Okay. So now when it asks you to do something like this, to graph it, it's asking you to confirm that on a graph that you're going to draw as well. It's a sketch, okay, so I'm not looking for artistic ability here. If we were, I would be in a lot of trouble because I really don't have any. But you're going to graph it looking something like that, right? Oh, you can't see my other screen. Me and technology, I'll tell you what. Okay, so it looks something like this, the corner that I'm looking in anyway, right? Like half of a W. And you had the tangent line that you can draw in that looks something like, that was not very good, something like this, right? This is the overall kind of look that you get. Again, you're not looking for a graph that tells you for sure you're 100% right, but if you screw it up, your graph will often tell you you're 100% wrong, right? If it shows a graph that just flat out cuts through the middle of the graph, if it looked like this, you would be wrong. You would know it. It doesn't look anything like a tangent line, okay? So this is more of a confirmation that it's a close value, that you've got something that's reasonable, okay? That you're not too far off. Any questions on this one? Okay, we have one more into 2.2. Determine the points, if any, at which the graph of the function has a horizontal tangent line.
That's where it's 0.
Yeah, what's going to be 0? The slope. So if you have a horizontal tangent line, horizontal means like this, right? Horizon. If you have a horizontal tangent line, it means that the slope is 0. And in particular, and we'll find out more about this later, but that happens when we have these dips in the graph, like a minimum is what we'll call it, and we have maximums or peaks and valleys. So we're going to use calculus to determine when that happens. Our calculator, just graphing it itself, can give us a lot of information. But again, that's not using calculus to determine that. So we're going to do this by finding the derivative and setting the derivative equal to 0. So our derivative, whoops, let me get back to my, now you see fractions here, but these fractions are a little different than the ones we had last time because the variable's not in the denominator, right? They're just numbers. So this is like having, it doesn't say it this way, but this is like having right here just 2/3 x cubed. You guys with me? So don't try to overcomplicate something that's really not meant to be that way. It is just a fraction 2/3. So if you have the fraction 2/3 and then you have an x cubed, the cube will be multiplied by the 2/3. So what's 2/3 times 3? It's just 2. And then we'll decrease the exponent by 1 to give us squared. This piece right here, same thing. This is really just 1/2 times x squared. Negative 1/2, but the negative is part of this automatically. So I have an exponent of 2 that I'll bring down. The 2 gets multiplied by the 1/2 to give me 1. Write it or don't, either way. And then the new exponent will be what? X. So this is 1x or just x. This is the piece I have left. What's the derivative of minus 3x? Minus 3, negative 3, yeah. And then the derivative of the 27? 0. Now we're supposed to, what we said a minute ago, set this equal to 0. Some of you have expressed either concern to me verbally, or I can see concern expressed by work you've turned in that factoring is not something that you feel extremely comfortable with at this point in your life. So if that's you, I would strongly encourage you to get some kind of a resource, whether it's online or something, and review some basic factoring techniques, because it's going to come up like continually throughout calculus, this need to factor. And it's not going to be like super complicated factoring. So I'm not asking you to go get the Algebra 3 or Math Analysis book from your high school that has the most complicated factoring under the sun. That's not the point. Okay, it's real basic factoring that we're going to see. So like on this one, for example, at the beginning, I know some of you are like, I can't believe she's going to explain this, and others of you are like, I can't remember how to do this at all. So I'm trying to balance both of the groups of people here. The 2x squared means I'm going to have two numbers in the first places that multiply to 2x squared. So the only numbers on this one that will do that are 2x and x. So those are givens. You don't even have to think about them. There's nothing else that's an option. The sign at the back is a negative. Because the sign's negative, it means the two signs here have to be reversed of each other. And you may not automatically know which one should be the positive one and which one should be the negative one. And honestly, it doesn't really matter. Just put them in, and if we need to switch them later, you're using pencil and you can erase. Okay? So I'm going to put them in as negative and positive, and I may realize that I may be wrong. Again, these two numbers at the end have to multiply to 3. Again, I don't have any choices. There's only two numbers that multiply to 3. They are 3 and 1. And again, I don't know that I'm going to get them in here in the right place because I'm not referring to my notes as I'm putting them in there. I'm just doing it haphazardly. 1 and 3. And I may have to switch them later, right? I might, and that's okay. So how do I check to see if this, in fact, is the correct one? I FOIL it. And I don't even really have to completely FOIL it. All I have to look at are the inside and the outside terms. Because I know I have the same first term, 2x squared, and I know my last term is minus 3. And I know that because those are how I chose the numbers. So I really only have to consider the inner and the outer terms. This inner term is negative x. The outer term is positive 6x. So that would give me positive 5. I don't have the right value at all, correct? If the value itself is wrong, it means that the numbers are in the wrong location. So the first thing for me to fix is the 1 and the 3 and switch them.
Is it okay to slide and divide?
Yes, there are other methods for doing this. Yeah, if you have another method you like, that's fine. There's also something called the AC method. That's one that I've used before. Because we're dealing with pretty simple, straightforward ones, I tend to just use guess and check. But if you have other methods you like better, you're welcome to use them. My inside terms on this one are negative 3 times x, so it's negative 3x. And the outside term is 2 times x, so that's positive 2x. So what is negative 3x and positive 2x? Negative x. And that's actually what I wanted, right? What if I had gotten a positive x?
Your signs are wrong.
My signs would be in the wrong place, and I just need to switch my signs. So this factoring is the correct factoring for our problem. Okay? Once we have it factored correctly, we can set each factor equal to 0. So 2x minus 3 equals 0, and x plus 1 equals 0. So 2x equals 3, x is 3 halves. And over here, x is negative 1.
Is this to find points? Is that what
These are the x values. Yeah, it says determine the points, if any, at which the graph of the function has a horizontal tangent line. So we're not actually answering the full question just yet. We just found the x values for it. If I have an x value, though, can I find a y value? Certainly. And if you want to do it by hand, you're welcome to. If you want to use your calculator to evaluate it, that's fine too. So I'm going to grab my calculator, and in y equals, I'm going to put in the function I was given. I was given 2x cubed divided by 3 minus x squared divided by 2 minus 3x and minus 27. Now, oh, thank you very much. Plus 27. That would change things, won't it? I am going to show you one thing about this that you may not be aware of. We have used the table to do this before, and that's fine. The problem is if I use the table for this specific one, what were my numbers? 3 halves and -1. The first one's just fine because it's a terminating decimal, 625. There's nothing wrong with terminating decimals, okay? I could actually write that down. It's got an exact expression, closed form, all good, okay? The problem on the next one is it's a repeating decimal. And yes, technically you can put a bar on top of that. That is a mathematical notation, but you don't really see that used very much, and I'm going to guess WebAssign probably doesn't have the ability for you to put a bar over something. They might tell you to approximate it to 2 decimals, and in case that would be fine. They might also just flat out expect you to turn this back into a fraction. So as you're looking at that, you might be thinking, okay, well, I don't really remember how to turn it back into a fraction from repeating decimal, or surely there's a way the calculator can help me with this. And there is. So I wanted to show you how your calculator can help you with this, but it's not inside the table menu. Okay? So I'd mentioned how to find vars before, that variables. So if I hit vars, yvars, function y1, and I put in the value I cared about, I think it was -1 that gave me the repeating decimal. So this is function notation. So this is like saying f of x, right? So this is the function evaluated at the point -1 for x. And if I hit equals, I get that ugly decimal expression, or at least the repeating decimal expression. Your calculator underneath math, the very first option says frac. And if you hit that button, it will take the previous answer and put it in as A and S, and it says frac, and if you hit it one more time, it will turn it back into a fraction for you, which is a handy feature to have. Because as great and useful as it is to be able to know how to turn something back into a fraction, that is not our point in calculus. Okay? I'm not interested in working through with you how to turn something back into a fraction today. If you really want to know, you can come see me in my office and I'll be happy to discuss it, but not today in class. So, on this one, at the -1 point, the ordered pair is -1, and then 173/6. Before I leave the screen, I'll just do the other one just so you can see it doesn't have to specifically be a repeating decimal that has the problem. If I did 3/2 here like that, and I still wanted, if I felt weird about it being in decimals, or maybe your question specifically told you to put it in fractional form, you can still do the fraction from here, and it'll turn it back into a fraction as well. So,
Mine actually gave me fractions in the table.
did it really? How very interesting. Is there a setting to do that? Huh.
Yeah, well, I put it in as a fraction and it gave it to me as a fraction.
That might be a feature of, yours is using math type, isn't it? That might be a feature of math type that the older versions don't have. That's very cool to know. So I have 3/2 and then 189/8. If you want to write that one as a decimal, of course, it's fine because, you know, it has the closed form.
And you don't have to use the feature like
Nope, I do not. We will use that for some other things later. You use the max minimum as using your calculator to solve the problem instead of to check the problem. Yeah. Okay, any other questions about 2.2 so far? All right.